Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over density and what it is and go over a few examples. So let's get into this. So what is density? So density is a simple way of putting it would be that it's the amount of stuff in a given amount of space. So more stuff in your space means more density. Less stuff in your space, less density. Or the bigger space you have for your stuff, less density. You're right. The smaller the space for your stuff, more density. So that's the easiest way to think about it. So if we were to write this out, is the the amount of stuff in a given amount of space. Okay, so we have amount of stuff and we have amount of space. Okay, so what do we mean by stuff? Well, in chemistry, we're talking about the stuff of matter, right? How much matter you have in your space. So matter is something that has mass and takes up space. That's what we mean by matter. So anything that has mass and takes up space is matter, and that's the stuff we're talking about. So we're going to measure the amount of stuff by measuring the mass. So this would be related to the mass of your stuff, right? And so the given amount of space, well, that's going to be the space taken up by the stuff, right? So that's going to be the volume. So we measure that by volume. And so when we think about the mass that's in the volume or the amount of stuff in the space, a lot of times we'll use the word per, right? So it's the amount of stuff per amount of space, or mass per volume. And what you remember from your math class, or you should remember from your math class, is that anytime you have something per something, miles per hour, meters per second, grams per milliliter, that per means that you are dividing the two things. So the first thing is divided by the second thing. So here we have mass per volume. So that means we're dividing the mass by the volume. So you should be thinking division. So what is density then? Density is equal to the mass divided by the volume. And we can use different units when we do this. So mass can be measured in different units, volume can be measured in different units. But typically what we usually have is we'll measure mass in grams and we'll measure volume in milliliters. So you have grams per milliliter here. Okay, or if you multiply grams by 1,000, you've got a kilogram. If you multiply milliliters by 1,000, you get liters. So you could also have that as your unit. So you have kilograms per liter, right? So that's another way. Another way would be instead of milliliters here, you could have centimeters cubed. Why is that? Well, one of the things you should know, and then I'm going to have you should memorize this. Your teacher wants you to memorize this, I'm sure. So 1 milliliter is equal to 1 centimeter cubed. Well, why is that? Well, it's true by definition. And what do we mean by centimeter cubed? Is if you have a cube, right? Here's my cube. Oops, that's not looking good. So there's my attempt at a cube. So this would be a cube, and let's pretend that this is 1 centimeter, and this is 1 centimeter, and this is 1 centimeter. So here we have a centimeter in width, we have a centimeter in depth here, we have a centimeter in height. So if you multiply the width times the height times the depth, you'll get a centimeter cubed. Centimeters times centimeters times centimeters gives you 1 centimeter cubed. So that would be the volume of a cube that has sides that are 1 centimeter. That by definition is equal to 1 milliliter. And I won't get into why that is, but that's something you should memorize. So make sure you know that 1 milliliter is equal to 1 centimeter cubed. And so if this is true, then we could replace milliliter with centimeters cubed. So you could have grams per centimeter cubed. That's also a unit of density. So you'll notice that the units of density are a mass unit divided by or over a volume unit. So grams per milliliter, kilograms per liter, grams per centimeter cubed. And so these are what we call derived units because they are derived from other units. So mass has its unit, grams or kilograms or whatever, and volume has its unit, milliliters, liters, centimeters cubed. Um, centimeters cubed would be a derived unit, but these would not be derived units. But the unit of density is derived from these other units, so kilograms and liters, grams and centimeters cubed. So these are different units of density. A lot of times you'll have, when you're measuring the density of a solid, usually you'll see grams per centimeter cubed. Usually when you are uh, reading or looking up the density of a liquid, it's going to be in grams per milliliter or kilograms per liter, right? So that's how you measure the density in different units. The other thing you want to know with regard to water, so the density of water, that is going to be 1 gram per centimeter cubed, or that's also equal to 1 gram per milliliter. So the density of water is 1 gram per milliliter or 1 gram per centimeter cubed. So the answer is 1. So 1 gram per milliliter, that is the density of water. That is something you should know, either in grams per centimeter cubed or grams per milliliter. Okay, and this is only true under certain conditions like temperature, right? So it's got to be at a certain temperature. Usually it's room temperature, which is 20, 25 degrees around there. But it's at a particular temperature. So the density of water is not always 1 at all temperatures. Like everything else, anything that has matter, the density is going to change based upon temperature. If it gets really hot, things tend to become wider. Things tend to grow in volume and therefore become less dense. When things get cold, things tend to shrink and become more dense. Same thing with water. So but this is still a good thing to memorize because usually we're working with conditions that are like normal conditions, room temperature conditions. So this is a good thing to know. Okay. So what else? So let's take a look at some examples. So here, if I have a box, let's say I have a box here and I have another box, and let's assume that these are the same volume. So if I have 1, 2, 3, 4, 5 in here, and I have 1, 2, 3, 4, 5 dots in there, or atoms, or molecules, or particles, if they have the same volume and they've got the same amount of stuff in the same volume, then these would have the same density, right? So the volumes are the same, the masses or densities or the amount of particles or stuff you have in there are the same. So let's assume these are the same particles, same kinds of particles, therefore you have the same number of particles, same mass. So same mass, same volume, same density. What if you have another one, same volume? Again, this might not be to scale. So assuming that these are all the same, if I have more particles, right? Let's say I have 4, 5, 6, 7, 8, 9, 10. Now I have 10 particles in there, right? So same volume, but twice as many particles. So that means I've doubled the density. So the density here would be twice as much as the density here because the volumes are the same, but the amount of stuff. So notice here in our equation here, I've kept the volume the same, but I doubled the amount of particles, which we're assuming is going to be double the mass because it's the same particles. So we're doubling the mass. So if this doubles, then we're doubling the density. So increase the mass while the volume is the same, you're going to increase density. What about if we have a bigger volume, right? We have a bigger volume, 1, 2, 3, 4, 5. So I have the same number of particles, but larger volume. So here we're comparing this one and this one. This one has more volume. Let's say, I don't know, let's say this is 4 times as big. So if I divide this in square, maybe it's about 4 times. So we've increased the volume by 4, it seems, right? So that means we've increased this bottom part by 4. We multiplied by 4, but notice it's on the bottom, so it's like decreasing by a fourth. So we've decreased this whole thing by a 4. So increasing the volume by 4 uh, decreases the density by 4. So increasing volume decreases the density. And you can see that here by looking at all that space there between the particles. That is definitely less dense than this one. So that kind of gives you an idea of how this equation works based upon how these are all related to each other. Okay, so I hope this is helpful. Some examples that we are familiar with, like, so you might know that things that are more dense tend to go to the bottom, and things that are less dense tend to float on top, right? If we're thinking about liquids and solids, right? So we have a few examples where you may have seen those colorful density columns, right? So you might have some sort of column and it's got these layers. I don't have one to show you at the moment, but you may have seen where you've got these liquid columns with different colors, and the one on the bottom is more dense and the one on the top is less dense. So as you go down the column, you've got more dense liquids, and as you go up, you get less dense liquids. And so you could also put a solid in here, like say a nut or a bolt or a peanut or something, and you could see that it'll like get stuck in one of these layers, and that'll kind of tell you the density of that particular thing as well. Um, you also see this with oil and water, right? So, for example, if you mix oil and water together, you'll see that the oil rises to the top and the water's on the bottom. That's because the oil is less dense than the water. And you see this with oil spills, right? So, with oil spills, anytime there's an oil spill, you'll see that the oil floats on the top, which is a benefit for cleanup because it's easier to clean something up and just get it off of the surface. If oil was more dense, then it would sink down into the water and it'd be a lot harder to clean up. So that's a good thing that oil is less dense than water, especially with oil spills. You also know of density with regard to the solids, right? So we know the earth, right? So we know for the earth, if you think back to your earth science classes, you know that the earth is made up of generally 3 main layers. So you've got the crust, and then you've got the mantle and the core. So you've got the mantle, and then you've got the core. Now, the core can be broken up into 2 different parts. You've got the inner core and the outer core. Here, the mantle can be divided into 2 parts. You've got the upper mantle, lower mantle. But these are the 3 main parts. And again, you can they're arranged by density. So the closer you are to the center of the earth, the more dense you are. So the core is going to be the most dense, and then the crust is going to be the less dense. And so this density comes in with tectonics, plate tectonics, right? And volcanoes. So, for example, if you have two plates coming together, right? If they collide, which one's going to go down, which one's going to go above? Well, the less dense one is going to want to go up on top. The more dense one is going to want to go down the bottom. And so you get those or oceanic ridge. You'll get that ridge or that kind of valley that's there. And then the one that's going under this is called a subduction zone. And so that's going to go under and that could be turned into lava and stuff like that. And so when lava is formed, that'll rise to the top because it's hot. It's been heated up. It's because of the temperature, it's been heated up and it becomes less dense and it floats to the top. And so also you may have remember you get these convection currents in the mantle, right? So the hotter the stuff down below is hotter, so it becomes less dense, rises to the top, right? And then it cools down here and becomes relatively more dense, and then it floats or down to the bottom again, gets heated up, and you get these convection currents. If you've ever boiled something in water like spaghetti or pasta or something like that, you'll notice the convection currents in the water as well. And so remember, the heating source on your stove is towards the bottom of your pan, and so it floats down, it gets heated up, and then the water goes back up because it's less dense. And then at this part, it's relatively cool, cools down, comes back down. You get those convection currents. And so those are a few examples of density. I hope this was helpful. If you enjoyed this video, if you learned something, if this was educational, then please make sure you like that button, hit it, smash it, and make sure you subscribe to my channel, hit that notification bell so you'll be notified by other videos I put out, and put a comment in the comment section so you can tell me what you think and ask any questions. Thank you for joining me and have a great day.